So last lesson we looked at the graph of f of x and f prime of x, so the derivative. This time we're going to look at the we're going to be given basically a function, and we're going to have to find all the things that we found from the graph. So where is it increasing or decreasing, and then all the coordinates of the relative max or min. So the first thing that we are going to look at is where f prime of x is equal to 0. Those are going to be called critical values, or critical, I guess you could say critical values, critical numbers as well. All right, so what we need to do first is find f prime of x, because we can't find what the critical values without finding f prime of x. So that's going to be 3x squared minus 6. And so to find the critical values, I'm going to set that equal to 0. So 0 is equal to 3x squared minus 6. And so therefore I will solve for x there. And then from there, I'm going to get the square root of 2 is equal to x. Well, don't forget that when we have when something is equal to x squared, then we also have the positive and negative of the square root. So don't forget about that. It's both of those values. So what we're going to do now is we're going to make a number line graph. So let's look and see. So if I have my number line right here, and I'm going to plot my critical values there. So I'm going to have negative square root of 2 here, and then the positive square root of 2 here, obviously with 0 in between there. And what I'm going to do is I'm going to see where is it increasing or decreasing based on the derivative. So I'm going to pick a value. So this is going to be f prime of x. And so I'm going to pick a value to the left of negative 2. So I'm going to pick, the negative square root of 2. So I'm going to pick negative 2. And I'm going to plug that into f prime of x. So that's going to be 3 times negative 2 squared minus 6, which is going to give us a positive 6. So since that's positive, this is going to be increasing. So this is going to be going up from left to right. And then I'm going to pick a value between the negative square root of 2 and the positive square root of 2. Something that's really easy is 0. So I have 3 times 0 squared minus 6. So that's going to be a negative 6. So this is going to be negative. It's going to be decreasing. And then picking a value to the right of the square root of 2, I'm going to pick positive 2 here. And so that's going to be 3 times 2 squared minus 6, which is going to give us another positive 6. So this is positive, it's increasing, and so it's going to be going up from left to right. So that's all of the value, everything I talked about above here when I talk about increasing is going to talking about f of x. The positive, negative, positive, that's talking about f prime of x. So I like to use the arrows to help me visualize some of the extrema a little bit better. So some things I want to note here is that f of x is increasing from negative infinity up to the negative square root of 2, unioned with the square root of 2 up to positive infinity. The next thing I want to note is that f of x is decreasing from negative square root of 2 to the positive square root of 2. So those are all in open intervals, okay? So this is increasing because f prime of x, and this is something that you want to make sure you note, f prime of x is greater than 0, and then I know that these are decreasing because f prime of x is less than 0 for those values. And then we also can note the extrema. Remember, if it goes from positive to negative, if the derivative does. So you can also follow my little arrows. I'm going to have a max here, and I'm going to have a min here. And so therefore, I'm going to have a relative, make sure you note that. Let's say this. Let's say f of x has a relative max at, and so I'm going to go ahead and x equals negative square root of 2. And why is that? Well, that's because f prime of x goes from positive to negative. And so the actual coordinates of that extreme of that max is going to be negative 1.414 and 6.657. So that's going to be for f of x, that's that relative max, that actual value. So you can find that by plugging this value in, or square root of 2 in for x, and then it will spit out your y into f of x. So make sure you note that. And then we have, I'm going to note this here, f of x has a relative min at x equals a positive square root of 2. Why is that? Because f prime of x goes from negative to positive. So it goes from decreasing to increasing again. And so that actual point is at positive 1.414 and negative 4.657. And that's the actual coordinate point there. Again, plugging in positive square root of 2 in for x into the original function, which is way up here, okay? The actual function f of x. All right, so that is if you have a polynomial. Now let's look at a trigonometric function. And so we're going to still find increasing, decreasing, relative mins and maxes, but we're just going to find it on the interval from 0 to 2 pi. So again, I need to find those critical values by finding f prime of theta. So that's going to be 1 plus 2 cosine theta, because remember the derivative of theta is just 1, and then the derivative of sine is cosine. So let's set that equal to 0 now. And so I'm going to have negative 1 is equal to 2 cosine theta. I'm going to divide by 2. And so the cosine of theta is negative 1/2 at 2 pi over 3. And, I say or, it could be, so theta equals this, and I don't want to say or, theta equals 4 pi over 3. Okay, so those are our critical values. So I'm going to do my number line here. And so I'm going to have, so remember I'm going to go from 0, so I need to note that. So I really am not going to have arrows at the end of my number line. I'm actually going to have some endpoints there at 0 and at 2 pi, since I already restricted that. So this first little tick mark is going to be 2 pi over 3, and the second one is going to be 4 pi over 3. And so now I'm going to find values of theta that are in between there, so that way I can decide if it's increasing or decreasing. So the value I'm going to pick between 0 and 2 pi over 3 is actually going to be pi over 2. So theta is equal to pi over 2. And when I find that out, you're going to get 1 plus 2 cosine of pi over 2, which is going to be positive. So our f of x is going to be increasing. So f prime of x is positive, so f of x is increasing, or f of theta, I guess I should say. So then between 2 pi over 3 and 4 pi over 3, I'm going to choose that theta is equal to pi. And so therefore I would have 1 plus 2 cosine of pi, which is going to be negative. So plugging in pi into my derivative, it's going to be negative, which means that my function is going to be decreasing here. And then between 4 pi over 3 and 2 pi, I'm going to choose theta to be 3 pi over 2. And so therefore, I'm going to have, whenever I plug this in, my f prime of x is going to be, or f prime of theta is going to be positive, so this is going to be increasing. So let's come over here and note a couple of things. I know that f of theta is going to be increasing from, let's see here, it's going to go from 0 to 2 pi over 3, unioned with 4 pi over 3 to 2 pi. And I know this because f prime of theta is greater than 0. The next thing I want to note is that f prime of theta is decreasing from 2 pi over 3 to 4 pi over 3 because f prime of theta is less than 0. Okay, so now we've taken care of increasing and decreasing. Now we need to find the max and min. So f of theta has a relative, make sure you note this, a relative max at x equals 2 pi over 3. Why? Because f prime of theta goes from positive to negative. So it goes from increasing to decreasing, essentially. So if I plug in f of 2 pi over 3, I'm going to get 2 pi over 3 plus the square root of 3. So where is this relative max at? And the exact coordinate is going to be 2 pi over 3, and then at 2 pi over 3 plus the square root of 3. And then lastly, f of theta has a relative min at x is equal to 4 pi over 3. Why? Because f prime of theta goes from negative to positive. And so f of 4 pi over 3 is going to be equal to 4 pi over 3 minus the square root of 3. So the exact coordinates of the min is going to be at 4 pi over 3, comma 4 pi over 3 minus the square root of 3. All right, so this one is a little bit uglier, and I guess you could go ahead and do some estimations for the extremas there if you wanted to, if you could use the calculator. If not, obviously you would just need to make sure that you are able to plug in those values there. And so we're looking at, this was just given a function, and so basically we got all the information that we would get from a graph, but it was given a function. And that's it for 2.6.